adhesive cement, you want to have not just adequate, but very good isolation. And so in this case, if you cannot achieve that, and I'm not saying that the rubber dam in all situations is absolutely necessary, but certainly it is the state of the art, and it is something that a goal that you should try to achieve. But in some cases, we can't do that. I'm not as adept maybe as others in doing, especially in the posterior, when we have subgingival margins, is to get a rubber dam in there. And so sometimes I have to rely just on a retraction cord. And in that case, I might want to change the cement. And in that case, that might to conventional cement, which is more moisture tolerant. And in that case, that might have an effect on the material that I'm using. Instead of, let's say, a lithium disilicate, I might want to go to a zirconium, which is much stronger and can be conventionally cemented. So I've made a kind of guideline, and this guideline, of course, is my own gleaned from my studies, with looking at the literature, listening to people that I trust and the people that I look up to, and also my own experience. And it won't necessarily be the same as others will tell you. You must listen to all the different opinions and learn as much as you can, and then you need to make up, of course, your own mind. So what I've done is I've put on the top at the horizontal, I've put on the four, let's say, groups of cements that are available today. They're grouped from right to left is resin modified glass ionomer cement, and then going from right to left. So then we have the self-adhesive resin cements. Those are, of course, adhesive now, and the self-etching resin cements, and finally the resin with a dentin bonding agent. You can see the little arrows on there. It shows that the bond strengths of these materials. Resin with the bonding agent, dentin bonding agent, is the strongest of these materials, and resin modified glass ionomer is the weakest. I've also drawn a longer line, or a thicker line, between resin modified glass ionomer cement and all the others, because the materials to the left are the adhesive cements, and the ones to the right are cohesive. In other words, what we normally call conventional cement. There's quite a difference between the two, and we'll go over that in a second. Then we'll come back to this, and I will try to explain myself, and then after that we'll go into the protocols of of how to cement with both of these types of cement. So let's look at the cohesive versus the adhesive cements. The cohesive cements, in other words, the conventional cements, when you use this, you must have a material, since these are the weakest cement, you must have a material that has high strength itself. So in this case, in the materials that are available today, I would say that they need to be either metal-based, or the zirconium. Those are two materials that I think that you can really cement cohesively, successfully. But in that case, since these are weaker cements, the preparation must have the required retention and resistance form, which of course means that it is much more invasive, and you're weakening the tooth structure. These materials are also easy to use. They're very user-friendly. They tolerate moisture much better than the adhesive cements, and they are low cost. So on the other side, we have adhesive cements where the material itself is not important in terms of strength, because even weak materials, as you saw before, in terms like feldspathic porcelain, which is the weakest material, can have a long life, can be successful over a great period of time if they are adequately cemented and strongly cemented. And the reason is, of course, that this is a strong cement. It adheres very well to both the restoration material and the tooth structure. And therefore, a retention and a resistance form is not required. It's always a good idea to build that in. It certainly adds to the strength of and the long-lasting ability of that restoration, but it's not adequate, not absolutely necessary, because in this case you're relying on the cement and not your preparation, which means, of course, that we can make these preparations much less invasive, and so we are saving tooth structure, always a good thing, and being more minimally invasive. But because these are rather technique-sensitive materials in terms of their cement, isolation and moisture control is a must. So that makes them difficult to use. They are also multi-step materials, and that makes the whole process longer, and of course the material itself more costly. A tip here, and something I will emphasize several times during this short lecture. One is that the enamel bond is predictable. That is the reason that veneers have been such a success. They are a success where you leave adequate amounts of enamel. That is, I could say that's probably the same for posterior restorations, especially if they don't have retention resistance built into the preparation. The dentin bond, on the other hand, is much less predictable. It degrades much more over time, and so it is something that we need to be wary about. When we have a lot of dentin, you might want to think about putting in more retention and resistance form in your preparations to back that up, rather than relying on your bonding material. What are the cements that we're using? Just to go over and make sure that we're all on the same page here, because there has been some problem with let's say nomenclature, so that we all know what we're talking about here. This is probably something that everybody uses, and there's no need to go over this much. It's resin modified glass ionomer cement. This is the kind of so-called conventional cement, I think, that most people mean by that word. It's, you know, that it's an acid-base reaction, and it does have some chemical bond to the tooth structure. It can bond somewhat to the restorative material, and there's one that I will mention about how to achieve a little bit higher bond strength. But the bond strengths are either to the substrate or to the tooth are not very high. So that mechanical retention is required when you use conventional cementation, and it doesn't reinforce the material, the structure of the restorative material to a great extent. So that is a limitation of these cements, but it is a user-friendly kind of thing. It is less expensive than, usually less expensive than adhesive cementation. What about the least strong of the adhesive cements? That would be self-adhesive resin cement. Self-adhesive resin cement is a composite cement, meaning it's resin, but all the requirements for bonding, etching, priming are built into the cement itself. There's no separate bond that you need with this material. But of course, you can understand that when you put everything into one bottle, that it will have the least quality, and these have, at least up until now, the lowest adhesive bond strengths. Their mechanical retention may be required on these because of their low bond strength to the tooth. So in other words, preparation. This has been a little bit of an area of controversy about how adequate these really are. But I will say, and I will repeat these again, I don't consider these materials strong enough to hold any of the materials onto a retentive prep. So whenever I use these materials, I want to make sure that the prep is retentive. The next category of resin cement, broad category, is self-etching resin cement. This also has, as before, a dual cure cement, but in this case, it's not the cement that's self-etching, it's the bonding agent that's self-etching. So if we look at this in relationship to the self-adhesive resin cement, the difference will be really is that there's a bonding agent involved, and that bonding, the etching and priming of the tooth is in the form of the bonding agent, not the resin cement itself. So again, when you separate out, it increases the quality. And as you can see here, it's a kind of internal, this is a company graph from their internal research. But the idea here is that they are comparing two self-adhesive cements, but they're also comparing it to their own self-etch resin cements. And you can see that the self-etch resin cement is much stronger than the self-adhesive one. Now, whether this company's self-adhesive resin cement better than another company's, that's wholly not the important thing in this graph. It could be better, it could be worse, I don't know. The main thing is that neither of them have enough bond strength compared to the self-etch resin cement. This was in 2008, I might point out, and the self-adhesive cements have improved, but they still don't really measure up to the self-etch resin cements. I did put in this slide of another self-etch resin cement. This, as you can see, has a dual cure resin cement and a two-bottle self-etch bond. The reason I put this here is because this the bond here is rather unique, and I really don't know if there's another company or a product like that. This material, the bond that I'm talking about right now, the self-etch bond, is chemical cured. It's not polymerized. It's not dual cured. It's not light cured. It's self-cured, which is unique, I think, right now at least, because I don't know of any material that will do that. So I just wanted to point that out. And then we come to what is probably the oldest material that we have in terms of resins, adhesive resins for cementation, and that is the resin cement with a bonding agent, with a dentin bonding agent. This material, as opposed to the others, although it comes in a dual cured form, it also comes in a light cured form. And that's important because when you're cementing, especially veneers, you really don't want to use a dual cured cement. You want to use a light cured cement. You want to give yourself adequate time, and there's plenty of possibilities for curing this material. In the posterior, you can use light cured cements. You could use actually heated composite. Many people have used that. I use that occasionally, but there is always a question about whether your light curing unit will reach